schedule. So what you will find is your referencing of your elements. So you have your base, your size of your base, number of, so there's one base, column size of your column, and then number of columns, your stirrups, number of stirrups. So what you see here is your each number in each base. So you have 20 of these bars of the Shapecoat 35s in this base. So what you want to do is, when you go to total number, you just say 1 multiplied by 20, you get 20. And then how they got the 2150 is they use this table to specify the n value for the formula Shapecoat 35. In Shapecoat 35 formula is a plus 2n, and in this case you're gonna say a plus 2n. So when you say a, you have your a distance, which is the total length, and how you determine your length is going to be your column size. So I just want to see if I have a drawing. Is your column size minus your covers on both sides. So your cover, they will specify it. You should see our cover is, depending on the design, 50 in the base, 15 millimeters. If it's underground, usually it can vary from 50 to 30. So 50 is usually underground, above ground is 30 millimeters your cover. So 50, so we say 1950 minus 50 this side, 50 that side, which is 100, and then that's how they got that. That's how they got that 1850 for your bar, your a distance. Now your n distance is the two bends going up, and when you come back, to the bending schedule, that's how they got that 1850. And then that's your a value. So now you just need to calculate your bends, which is your 2 up. So the formula here, like I said, that formula is for your Shapecoat 35. That formula is a plus 2n. It's a plus 2n. So a plus 2n, we're gonna say a, your a value, which is 1850, plus your 2n, which is 2, and your n is 150. And then you end up with 2150, and that's how they got the 2150. That's the length for one bar, the two bends plus your a distance. That's the length basically for, let me show you, for this one bar. So the two ends, which is your n values, the 150 that side, 150 that side, and your a is the 1850 is the total length. So that's the length. So your total length for one bar is basically the 2150. So now, since we have 20 bars, since we have 20 bars from here all the way down to there, since we have 20 bars, since we have 20 bars from your top, from there all the way to there. I don't know why I made it 10, it's supposed to be 20, but since we have 20 bars, we multiply one total length with 20. So when we say that, multiply by 20. When we say 2150 multiply by 20, we end up with 43000, which is a total length, your over total length. And then you need to calculate your mesh. So how you calculate your mesh, since this is millimeters and that's kilogram, you go to a table. You need to find that table yourself where they give you the kilograms per meter. Then you convert from millimeters, you convert from your millimeters to your meters, which is going to be, okay, basically I'm just gonna convert this, but they did a conversion on one bar. So I'm going to do a conversion on this. So they multiplied with 10 to the power minus 3. and they get 43, and then let's say they have 0.88 kilograms per meter, so they multiply 0.888, and then they're supposed to get a mass, a total mass, which is, let's just go back there, which is at 38, which is at 38.184, and that's how they got the mass, the total mass, 38.184. And that's how you calculate your mass also for your bending schedule. So that's how you determine the weight that you're gonna need, or the weight for 20 of these bars. So usually when you add up all of them, then you know the load that your truck is going to carry. So that's when you do the calculation on all of them, and that's how your bending schedule works.